Let us now wrap up this unit. We have seen that verification must come before validation. Verification is a standard procedure after each implementation step. It should reuse semi-analytical or analytical results of our mathematical model. What we expect is a point landing, meaning at most, let's say 1 or 2% deviation, and this deviation is always a compromise between computational expense and being precise. Validation is a benchmarking of the model and its assumptions. It also validates whether the verification was successful. However, it cannot replace verification. And the reason for this is simple. The errors introduced in verification cannot be corrected in the validation step anymore. The next term we have to deal with is calibration. This word means that we use experimental data to improve our initial estimates of parameters. This is typically an iterative procedure or can also be based on a response surface. Important to notice that the gain set of calibrated parameters is valid for a specific set of calibration experiments only. Therefore, it is important that the set of experiments must be close to the final application you have in mind. For example, the stress levels should be comparable and also the flow mode should be comparable. Of course, because calibration relies on experimental data, it's important that you trust your experiments. So we recommend at least a triplicate measurement for each operating point. The calibration setup has a certain sensitivity to model parameters. For example, in our dynamic angle of repose in the rotating drum setup, if you look closely, you see that the angle of repose is much more sensitive to the particle-wall friction coefficient than to the particle-particle friction coefficient. So if you go along this line here, there would be no change in the response. So this is important to understand. Also, please don't confuse calibration with validation. Of course, we need to have a separate data set from the experiments for validation and calibration. If you use the same data set, the validation step is essentially useless. Finally, if you're doing a parameter tuning, one parameter at a time, to improve validation results, this can be very dangerous because, as you have seen, these response surfaces can be complex shaped. This is it for this unit. I hope you enjoyed it. See you in the next unit.